All right, this video is going to show the solutions to the last three problems, 11, 12, 13, and 14, solving quadratic inequalities. So first thing I'm going to do on number 11, I don't like having my quadratic on the right side. So I'm going to switch it. Notice the inequality has to reverse here because it says x, read it backwards, x squared plus 5x minus 6 is less than or equal to 0. Isn't that what it says right here? X squared plus 5x minus 6 is less than or equal to 0. Right? Or the 0 is greater than or equal to if you read it backwards. Okay, so what I'm going to do is I'm going to look at that x squared plus 5x minus 6 and see if I can get it to factor. Now that I have the side switched, I'm a little happier. So I'm going to do a times c (1 times negative 6). I'm going to look for two numbers that multiply to create negative 6 and have a sum of 5. That's going to be negative 1 and positive 6. They will add up to 5. I'm going to draw the box. I'm going to put the first term in the first square, last term in the last square. Middle term gets split as a negative x and a positive 6x. Greatest common factor for the top row, for the bottom row, for the first column, these numbers right here, or these terms I should say, x squared and 6x are both divisible by x. They both have a factor of x. Negative x and negative 6, common factor is negative 1. Double check your factorization. X times x is x squared. X times 6 is 6x. Negative 1 times x is negative x. Negative 1 times 6 is negative 6. If I add all four of those together, I get my original polynomial x squared plus 5x minus 6. So our factorization, x minus 1 times x plus 6 will work. Remember, our first job is to find the zeros of the quadratic. We're almost there. When is that factor equal to 0? When x is positive 1. When is x plus 6 going to equal 0? When x is negative 6. So the zeros of our quadratic are x equals 1 and x equals negative 6. Remember, our next step is to draw a number line, put the zeros on that number line, remembering that because the inequality has an equal sign with it, they need to be little closed circles. So we're going to put a closed circle at negative 6. We're going to put another one at positive 1. Now, with this particular example, I'm going to do the sign chart. All right, let's remember how the sign chart works. So I'm going to put the factors x minus 1 and x plus 6, and I'm going to analyze where they're positive and where they're negative. And then I'm going to look at the product of those, because in the end, I want to know when this product is greater than or equal to 0, when it is positive, or less than or equal to 0. Right? Our inequality, when is that product less than or equal to 0? So we're looking for the negatives. We need the negatives. Right? So I'm going to do x minus 1 first. X minus 1. Notice it's going to be negative until we get to x equals 1, and then it's going to switch to positive. Think about that. When is x minus 1 going to be a positive? When is it going to be greater than 0? When x is greater than 1. Other than that, it's going to be negative. So we're going to do negative, negative, and then at x equals 1, that factor x minus 1 switches to a positive. X plus 6 is going to be negative until it gets to negative 6, and then it's going to switch to positive. The product, negative times negative is a positive. Negative times positive is a negative. And positive times positive is a positive. What I needed was the negative because I need the less than or equal to 0. So I need the negative. I'm looking for these guys. So my solution is going to be everything between -6 and +1, including the -6 and the +1, right? So with interval notation, it will look like that, and that is our solution. Okay, example number 2, moving on. It is not going to factor. Look at this. A times C is 6. Are there two numbers that will multiply to create +6 and add up to -10? -1 and -6 only add up to -7. -2 and -3 only add up to -5. That's all we got. Okay, so since it doesn't factor, we're going to use the quadratic formula. Oh, I am going to switch sides here just to make it easier for me to see what's going on. 3x squared minus 10x plus 2 is less than 0. Is it less than? Nope. When we switch the sides, look at the inequality. Which one's bigger? The 3x squared minus 10x plus 2 has to be the one that's greater. So my symbol needs to switch to a greater than. All right, so since it doesn't factor, I'm going to use the quadratic formula. So I'm going to go -b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to do negative, or the opposite of -10, because b is -10, plus or minus square root of. Now, a lot of you are forgetting to put that in parentheses. It has to be -10 squared, not without the parentheses, right? -10 times -10 is going to turn into a +100. Some of you are forgetting those parentheses. Okay, -4, or subtract 4 times a times c. A is 3, c is 2. All over 2 times 3. Okay, we're going to do some simplifying. We get 10 plus or minus the square root of. That discriminant is going to be 100 take away 24, which is 76. Grab your calculator, do the calculations. We get 76 divided by 6. Okay, we're going to do decimal approximations for this. So we're going to grab a calculator. We're going to do 10 plus the square root of 76. Whatever decimal that is, we're going to divide it by 6. Or you use parentheses on the calculator. But when we get the decimal approximation there, when we use the plus sign, we get 3.2 or 3.12. We're rounding it to hundredths, 2 decimal places. Notice right there, 2 decimal places. So 3.12. And then the other one, we use the minus sign, 10 minus the square root of 76. And then divide by 6, we get 0.21. And we round it to the nearest hundredth. Okay, now we're going to treat this one a little bit differently, or solve it a little bit differently than the other one. Notice we are going to use open circles at our zeros. These are the zeros of the quadratic. We had to round them because they weren't rational numbers. Okay, so what we're going to do is we're going to draw the number line. Actually, you know what? Let me do one other thing here. I'm looking at the function f of x equals 3x squared minus 10x plus 2. I'm looking at that quadratic. And I'm trying to figure out where the y values are greater than 0. So that's going to happen when the graph of f and the graph of the function is above the x-axis. So as I draw my number line, and I'm going to extend my page just a little bit here. As I draw my number line, I'm going to split it or put the zeros on the number line. We're using open circles this time because the greater than 0 doesn't include an equal sign. So 0.21 is over here. 3.12 is to the right of it. It's greater than it. We're using open circles. Okay. I'm going to do a little sketch of my function f of x. A is 3, so my quadratic, my parabola, would be opening upward. So where is it going to be above the x-axis? This is my x-axis. I've plotted the zeros on there. Y-axis is over here somewhere. It's going to be greater than 0. The y values are going to be greater than 0 when we are to the left of 0.21, okay, and when we are to the right of 3.12, okay. So our solutions, let's write them using interval notation to wrap this up. We're going to do negative infinity to 0.21 union with 3.12. Those are parentheses. 3.12 to infinity. And we're finished. Okay. Well, let's look at 13 and 14. Problem number 13. We've got negative 4x squared plus 5x minus r is less than negative 5. So the first thing I'm going to do, I'm going to add a 5 to both sides to get my 0. We need the 0. Now, what I don't like about this is I don't like my leading coefficient being a negative. So what I'm going to do is I'm going to multiply both sides by -1. Whatever we do to one side of an inequality, we have to do the same thing to the other. But what we need to remember is when we multiply both sides of an inequality by a negative number, or if we divide both sides by a negative number, we must flip the direction of the inequality. We have to reverse it because negatives on the number line are backwards. That's kind of why. 2 is less than 3. But if we multiply both sides by a -1, -2 is greater than -3. See that flip? Has to change. Okay, so multiplying both sides by a -1, the inequality has to reverse directions. So we have 4x squared minus 5x is greater than 0. You can try factoring, but it's not going to factor. I can't find a combination that's going to work, so I'm going to use the quadratic formula. So x equals, try it, it doesn't work. We're going to do x equals the opposite of -5 plus or minus the square root of -5 squared minus 4 times 4 times -5 all over, remember negative of b, plus or minus square root of b squared minus 4 times a times c all over 2a. We do some simplifying. Under that radical, we have 25 plus 4 times 4 times 5, because the negative times the negative will turn into a positive. 4 times 4 is 16. Times 5 is 80. We get a discriminant of 105. Use a calculator or whatever, but if you do, be super careful with it, right? You're doing negative. If you use the calculator, put in the parentheses, and you've got that, right? That's going to be 25 plus 80, which is 105. All right, all over 8. We're going to get decimal approximations for these. 105 is not a perfect square. We get -0.66. We're still rounding to hundreds. And the other one we get 1.91. All right, I'm going to draw my number line. Oh, actually, I'm going to write down my function that I'm working with. F of x equals, we're looking at 4x squared minus 5x minus 5. That's the quadratic that we're looking at. We want to know when it's greater than 0. That is going to be greater than 0 when the graph of the function f is above the x-axis, because f of x is y. So we're looking at where the y values are greater than 0. So if we were graphing the quadratic, y equals 4x squared minus 5x minus 5, it's going to be greater than 0 when your function is above the x-axis. Okay, so just a little quick analysis here. So we draw our number line. We'll put on there the zeros. Are we doing closed circles or open? We're doing open because there's no equal sign with the inequality. We've got our 1.91. We've got our negative 0.66, and they're open circles. And we are looking at a quadratic that opens, let me use green this time, upward, because A is positive 4. It'll go way lower than that, but I just need to know that it's below. And where's it above? Over here on the left of negative 0.66. And over here on the right of 1.91. Let's write our answer using interval notation. I need to do page extension here. So we'll go from negative infinity to negative 0.66 union with 1.91 to infinity. And there's our answer using interval notation. The graph is already shown. Okay, let's do the last problem. Problem number 14. So the first thing I'm going to do, I think I'm going to switch colors. First thing I'm going to do is subtract a 35 from both sides so that I have my quadratic with a positive leading coefficient. A is positive 1. But I don't like having the variable on the left side or right side, so I don't like having the variable on the right. I want it on the left. So I'm going to switch sides. X squared minus 2x minus 35 is greater than or equal to 0. Read it backwards. X squared minus 2x minus 35 is greater than or equal to 0. And then I'm going to see if I can factor that. I've got negative 35, and I need two numbers that multiply to create negative 35 and have a sum of negative 2. All right, that would be positive 5, negative 7. We get sum of negative 2. We go through the steps of factoring using the table. And I think in the interest of time, well, actually, let's just do it. So, check all the box. First term gets the first square, last term gets the last square. Middle term gets split into a 5x and a negative 7x. Greatest common factor for the top row. Greatest common factor for the second row. Greatest common factor for the first column. And greatest common factor for the second column. Does that work? Yep, it does. Factors as x plus 5 times x minus 7. We want to know when that product is greater than or equal to 0. So we find the zeros of our quadratic. This one's going to happen when x is negative 5. This one's going to happen when x is 7. We draw the number line and put the zeros on it. This time they're going to be closed because there's an equal sign with that inequality. So we're going to have a 0 here at -5. We're going to have 1 over here at 7. And I think, again, this time I'm going to use the sign chart so we can see how it works again. We've got the factor x plus 5. We've got the factor x minus 7. And we've got the product x plus 5 times x minus 7 that we're trying to analyze. The zeros of our quadratic split the number line into 3 different intervals. And those intervals, let's see what happens. If we put in something less than -5, like a -6, -6 plus 5 is -1. It's negative here. But if I put something between -5 and 7, like even a -4, -4 plus 5 is now positive. See how that switches at -5 and it remains positive forever. X minus 7, that factor is going to start out negative and it's not going to switch until I get to 7. Think about it. If you put in -6 or even a -5 for the x, -5 take away 7 is -12. Okay, -6 take away 7 is -13. If we put in a 0 for x, 0 take away 7 is -7. But when I hit 7, that switches to being a positive factor. Okay, now look at the product. Negative times negative is positive. Positive times negative is negative. Positive times positive is positive. What were we looking for? We need the positives because greater than 0 is positive. So what we're going to have is these two intervals. Interval on the right and the interval on the left. Okay. There's the graph of our solution intervals. And then to write them in interval notation, we'll go -infinity to -5, union with, notice we're using brackets because of the closed circles at the endpoints, and we are done. That's the end of our review.